So, Catherine, you spend quite a lot of your time traveling around the world with observatories in schools.
That's
Can you
right.
tell us a little bit about that?
I'd be glad to. So once I started to realise that optical spectroscopy on some of these relatively low mass black hole systems in our galaxy, we call these microquasars, once I realised that optical spectroscopy was a really powerful tool in the toolkit, I started to realise that if one could have continuity in the coverage of the different objects that I wanted to study with optical spectroscopy, that it really could lead to quite a few advances in monitoring the behaviour of these objects, particularly in a cause and effect sense. So following how the matter gets attracted towards the black hole, the word we use is accretion, and then how the matter gets expelled from nearby the black hole in the relativistic jets that I mentioned earlier. But it's actually quite difficult to get the continuity of coverage in time that you need to match the timescales that these objects actually evolve on.
Yeah.
We're used to thinking of the sky as a very beautiful place, which it is, but we can be tempted to think it's a very static, very serene place, which it is not. The sky in general, but these microquasars in particular, are very dynamic objects, and they're evolving, some of them on timescales of hours and days. Now, there's no way that from one of the established professional observatories you can have all the nights on that telescope in 1 year. Even if you could, there's a real problem, which is that you can't do optical astronomy during the daylight. Light from the sun absolutely swamps light from all sorts of stars, unless the sun is the other side of the planet and we're not getting any sunlight. So in order to overcome this, what I thought would be the thing to do would be to deploy a network of observatories separated in longitude, so that at any time on a 24-hour clock there was at least one of these in darkness, and hence it could make observations. So here's one in Chile. Then there's a bit of a gap with the Pacific Ocean. Then we have our Eastern Australia Observatory, then our Western Australia Observatory, then India, and then South Africa.
Okay, wow. So there's 5 of them?
There's 5 of them.
Yeah. And so you're always getting this data in here in Oxford?
That's right.
24 hours of the day?
So pretty much, if it's rainy or cloudy, then we don't observe. But otherwise, after local bedtime, I will be observing remotely over the internet, and then the data will come back over the internet for processing here in Oxford.